Hello, 7th grade. Welcome to your first online lecture with me, Miss B. Um, this is how I'm going to do your lectures for the next couple weeks while we're all hiding from the coronavirus. If it's any like audio problems or anything, please let me know. Uh, Sorry for the quality. My webcam's not great. Yay. Also, if I sneeze or anything, I promise I'm not sick. The pollen's trying to kill me. I hate it. Anyway, so our first lecture is going to be about mutations. So if you have not already, what I need you to do is go into your class Google Doc and click the link that says lecture slides or video slides. I have made my PowerPoints available for you all on Google Slides. So if you haven't done that, go ahead, pause the video, do that now. What you'll be doing is following along with me talking and the slides. I haven't put on all the information on my slides just like usual. So what you'll have to do is take notes on what I say as well. If you want to print out the slides, go for it. Or if you just want to write it on paper, go for it too. But make sure you write down the things I say as well. Nice thing about this is that you can pause the video and watch it as many times as you want. Get me those views, guys. Alright, so your warm-up is I want you to find what has changed in the DNA sequence. If you don't have the slides in front of you, get them out. If you do, anyway, here is the sequence. Can you see it? Yes. This is the sequence, and I made one single change between the old strand and the new strand. See if you can find it. Alright, I'm going to circle it for you now. I made one tiny change. Oh, my marker's dead. It's dead. This is great. Sorry about that. No fun colors today. I changed this one G into a C. And that is called a mutation. And that is our subject for today. So you may be asking, what is a mutation? And a mutation is any change in the DNA sequence. You can put a new nucleotide in, you can take one out, you can just trade places. There's lots of different kinds of mutations. We're going to cover 3 basic ones today. A disclaimer is that just like how we talked about with Dr. Pridgeon, Ms. Laura, who did our sickle cell, not all mutations are harmful. In fact, a lot of them can be helpful, and most of the time they're harmless, right? They're just a change. They're what make us different people. Yes, certain ones can give you illnesses or whatever, but most of the time mutations are just that. Tiny little changes, and that's it. So there are different kinds of mutations. Think about X-Men and Marvel and all that. So Cyclops from Marvel, he's a guy that can shoot lasers with his eyes. He's blind. He was born with that mutation, so it was like a natural mutation. He was born with it. Something in his genetic code went wrong when he was in the womb. Excuse me. Whereas compared to Spider-Man, Spider-Man was bitten by a radioactive spider, right? Peter Parker. Peter Parker got bitten by a radioactive spider, and then he turned into Spider-Man. He had all his spidery abilities. This was caused by something in his environment. Mutations can happen like throughout your life. That's how things like cancers are. Usually mutations, well, almost always mutations that happen throughout your life is something due to your exposure to something in your environment, whether it be like gamma radiation in the case of Hulk, or even sometimes forms of radiation to get cancer. So that's the basic difference. Some are naturally occurring or occur, before birth. Some occur throughout life, and they're caused by their environmental change. So 3 examples of mutations that we'll be covering today. We'll go into more detail each. Insertion, basically where you put another nucleotide base into the sequence. A deletion, where just by its name you can tell it takes something out. And a substitution, that was the one we looked at in our warm-up, where I traded nucleotides. So the very first one is insertion. And while you're copying that down, I'm going to copy down the DNA sequence for you to look at. So an insertion is where a nucleotide is added or inserted to the sequence, so it's going to be a bit longer. So we have our A, C, T, G, C, A, G, G, T. That was our original. Then we have A, C, C, T, G, C, A, G, G, T. And if you haven't found it already, it's this extra little C right after the A. That was what was inserted into our DNA sequence. And if you think about it, this now has to shift the whole line of nucleotides down, for lack of a better word. So now you're going to have a bunch of different results. Our next example is a deletion, where simply you delete something. You take something out. As with all these mutations, it can be as small as one nucleotide, or it can be a whole group. It really depends on what happened. We're going to mostly work with just, really going to work with just one change. Make life simple. So A, C, T, G, C, A, G, G, T. And now we have A, C, T, G, A, G, G, T. So see if you take a second and find where that went wrong. If you did, you should have found that the C after that first G in our old sequence was deleted. It's gone now. Alright. Our last example is substitution, just like we did in our warm-up, and it's where you trade one nucleotide for another. Okay? So this is also called a point mutation, so if you ever hear me call it that, it's the same thing as substitution. So our old line is A, C, T, G, C, A, G, G, T. And our new line is A, C, T, G, A, G, T, T. I didn't write this very neatly, but you should see that this little T and G, this G, it didn't line up. They were switched. I made this G into a T. And it's called a substitution because you're subbing something else in there. Just like when you have a substitute teacher. It's a different teacher. They're still doing something. They're still teaching you, right? This is still coding for something. It's just a different nucleotide. Excuse me. So what happens after a mutation occurs? Let's go back to protein synthesis. That was all the stuff we were doing with transcription and translation and the RNA. Remember, every strand of DNA codes for RNA. In our case, with protein synthesis, it's coding for messenger RNA, or mRNA. So, if we take the strand of DNA that is, I already grouped it into codons for you, you're welcome, A, C, G, T, T, A, G, I'm running out of room. So, take a second, find the RNA complement for that one. You guys are good at this, don't forget U's. T trades for U and RNA. Okay, so you should have something like, the answer is in the bottom right corner, really tiny. But if you can't read that, it should be U, G, C. A, A, U, 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 C. All right? So that's what you should have. That's your RNA complement. And if we recall to our codon chart, that thing where you could have first position, second position, third position, I'm just going to give you the proteins. So UGC codes for cysteine. AAU is ASN, or one of the acids, and then UUC is the LALA one, phenylalanine, but I call it LALA, as you know. Ta-da! So this RNA codes for these amino acids. So what happens if we change something in this DNA sequence? Well, you think about it and you go, well, I know that if I change something in the DNA, that has to change something in RNA, right? Because if I trade a G for a C, that C is now going to return a G in the RNA. Or better example is if I trade a T for a G. So instead of outputting A, it'll now output C. And as we know, all the codons from our chart are all made up of different little 3-letter chunks. And so it basically spits out new amino acids. So let's look at that slide that says change in DNA equals change in RNA, which is what I was just talking about. So we have our old DNA, which we just looked at. So let's put this into 2, and hopefully I'm able to write tiny. So A, C, G, T, T, A, G. That's our old DNA. Our new DNA has been changed into ACG, TCA, AAG. So take a look at this for a second and see if you can find the mutation, and then before I tell you, tell me what kind of mutation it is. Pause if you haven't got it yet, it's about to tell you. Alright, so looking at it, if you look in that second group of the nucleotides, you'll see that I traded that second T for a C. And if I traded it, that means it's a substitution. Okay? So if we look at the RNA, go back to what our little RNA strands should have been from the old DNA. Old RNA would be UGCAA UUC. Bunch of U's in there. And our new RNA, see if you can figure it out. I mean, it's on the screen in front of you, but I know you're smart. It should now be, remember to base it off of your new DNA. So you're going left to right in this. So it should be UGCAGU, UUC. So our one, where'd it go? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our 1A, excuse me. Ta-da. I had to count sequences because mine didn't line up. Alright, so our 5th position, this thymine, got mutated into a cytosine. Now if we look at the RNA complement, in the original, because cytosine spits back guanine, up here, thymine spits back adenine. But now because it's a cytosine, it spits back guanine. And that's a mutation. So look at your slide, and our old DNA spit back RNA that gave us cytosine, asparagine, and phenylalanine. Now, what the new RNA spits back is we had one single nucleotide change, and that AAU turning into AGU, if you follow the chart that's on one of your old homework papers, it now spits back as serine. So it's cytosine, serine, phenylalanine. So a change in DNA results in a change in the proteins that are made. Pretty logical steps, right? Sometimes a mutation may still spit back the same exact amino acid, because remember, like in the example of proline, proline fills that whole one box, right? It's like AA, I believe. Well, AA, first position, second position, as long as it's A, it's going to be proline. Double check me on that one. I don't have the chart memorized. So if you look at that, even if I change that third position on the proline, here, let me double check that because I don't want to be wrong for you guys. Codon chart. Where'd it go? Oh, I was off by one. It's threonine. I apologize. So, and it's AC. Miss B's tired. I'm going crazy. So if you look at the first position on threonine, it's always going to be A. And then it's always going to be C in the second position. So even if you change that third position, like let's say your original DNA was AGA, but it gets mutated to AGG, it's still going to spit back either AC or ACC, and that's threonine. Okay, so sometimes the mutation does nothing, which is a lot of times, which is just traded the code for the amino acid. Alright, so the big idea from today was that pretty green slide that says change in DNA means change in RNA, means a change in the codons, which means a change in the proteins. So all in all, when you change something in the DNA, you change a protein. All right, so your guys' homework for tonight is that mutation worksheet. It's linked on your Google Doc, and all you have to do is go through the DNA sequences, the first three of those, and you have to tell me whether it's insertion, deletion, or substitution. Simple enough. The last part, number 4, the challenge question, is I give you a DNA sequence, and you have to, well, an old and a new, you have to tell me what happened. Then you have to put them both into RNA and tell me what amino acid this fits back. So if you have any questions, please email me. I'm going to have my email up all day these 2 weeks, and just feel free to shoot any questions my way. You are going to be having a quiz on, what day did I schedule that? You're going to be having a quiz on this stuff on Thursday. So it's going to be all the way from RNA through transcription, through translation, and mutations, okay? I'm gonna give you 2 days to do it in case like you're sick or you forget. As long as it's in by Friday at 11:59 p.m., so right before midnight, you'll be fine. It's gonna be a Google form, and you're just gonna fill in the answers. Because we kind of went through this stuff really quickly, I will allow you to use notes to do it. I will provide a codon chart for you guys, so you don't have to like find one yourself. Yeah. So tomorrow I'll have a bunch of review sheets ready for you for Wednesday. And yeah. All right. So please, if you have any questions, email me. I'm available. And wash your hands, please. Bye.